Black holes are widely known as the scariest objects in space, and yes, they truly deserve that reputation. But there are far more frightening events that can make black holes seem almost irrelevant. But let's start with supermassive black holes. At the centers of galaxies, there are supermassive black holes. These contain millions or billions of times the mass of the Sun. Some of them are active, meaning they pull in gas and stars and release jets of radiation that can extend for thousands of light years. We don't know why they exist and how they form. Stellar black holes form when very massive stars collapse at the end of their lives. All the mass of the stars squeezed into a single point called a singularity. But they are tiny compared to supermassive black holes. And the strange thing is, there are no sizes in between, forming the question how supermassive black holes became so huge. One of it feeds so aggressively that it can even outshine its entire galaxy. Any planet in that region would be sterilized by radiation. At the center of our own galaxy lies Sagittarius A, a supermassive black hole with more than 4 million times the mass of our Sun. And even more extreme is TON 618, one of the largest black holes ever found, holding the mass of over 60 billion suns. But black holes doesn't look so scary anymore if we talk about gamma-ray bursts. Gamma-ray bursts are among the most dangerous events in the entire universe. They make even supernovae look weak. These bursts are the brightest and most violent explosions ever observed. A gamma-ray burst can occur in two main ways. The first is when a massive star reaches the end of its life, its core collapses, and a black hole forms. The second is when two neutron stars, the ultra-dense remnants of dead stars, spiral into each other and merge. In both cases, the energy released is catastrophic. In just a few seconds, a single gamma-ray burst can unleash more energy than our Sun will release over its entire 10 billion-year lifetime. The energy doesn't spread evenly in all directions. Instead, it is concentrated into narrow, deadly beams that shoot out across space at nearly the speed of light. If one of those beams were to point directly at Earth, the results would be devastating. The radiation could strip away our planet's atmosphere, destroy the ozone layer, and leave the surface exposed to lethal cosmic rays. Such an event would cause a mass extinction in a matter of days. Scientists have even suggested that gamma-ray bursts may have triggered extinction events in Earth's distant past, wiping out huge portions of life in an instant. When a massive star explodes in a supernova, the outcome depends on how heavy its core is. If the core isn't massive enough to collapse into a black hole, it can instead form one of the strangest objects in the universe, a neutron star. A neutron star is a sphere only about 20 kilometers across, small enough to fit inside a city, yet it contains more mass than our Sun. To put that into perspective, a single teaspoon of neutron star material would weigh several billion tons on Earth, firing beams of radiation into space as they turn. When these beams sweep past Earth, we detect them as pulses, which is why such neutron stars are called pulsars. Their extreme density and speed push the laws of physics to the very limit. But there is an even more dangerous variety, the magnetar. Magnetars are neutron stars with magnetic fields 1,000 times stronger than a typical neutron star and trillions of times stronger than Earth's magnetic field. This magnetic power is almost impossible to comprehend. It can twist and snap the very fabric of space around it. It can rip apart atomic bonds, destabilize molecules, and destroy electronics across large distances. But not all cosmic dangers stay in one place. Some wander through the galaxy like silent intruders. Rogue planets are worlds that have been violently thrown out of their solar systems, often after close encounters with massive stars or giant planets. Once ejected, they drift endlessly through space, frozen and dark, with no star to warm them. Astronomers estimate that for every star in the Milky Way, there could be several rogue planets. That means there may be hundreds of billions of these lonely worlds, traveling unseen between the stars. The most dangerous wanderers of all are rogue black holes. They are nearly invisible, detected only by the way they warp the space around them. If one passed close to our solar system, its gravity could send Earth spiraling out into frozen darkness, or worse, drag us directly into the Sun. Astronomers constantly track the positions of nearby stars and massive objects to minimize the chance of surprise. Still, the Milky Way is a galaxy of 100,000 light-years across, filled with countless wandering bodies. At any moment, a rogue traveler could be silently heading our way, unseen until it's too late. Then there is dark matter. It is one of the deepest mysteries of the universe. It makes up about 85% of all matter, yet we cannot see it. It does not emit light, it does not reflect it, and it does not absorb it. To our instruments, it is almost invisible. Its presence is known only through gravity, the hidden pull that binds galaxies together. Without dark matter, galaxies would not exist in their present form. Stars would simply fly apart into the emptiness of space. It is the invisible framework that holds the universe together. The danger of dark matter lies in how little we understand it. Scientists do not know what it is made of. It could be exotic particles that barely interact with normal matter, or it could be something even stranger. Entire structures of matter that are completely beyond our current theories. Some ideas suggest that dark matter could interact with itself in unknown ways. Dark energy is even stranger. It makes up most of the energy in the universe and is driving the acceleration of cosmic expansion. This means galaxies are moving away from one another faster and faster. In the future, the expansion could become so extreme that galaxies, stars, and even atoms are torn apart. This scenario is called the Big Rip. If it happens, it would be the ultimate danger, the destruction of everything in the universe. Scientists do not yet know if the Big Rip is certain, but dark energy shows us that the fate of the universe may not be survival, but destruction. Galaxies are not fixed in place. They move through space, pulled by gravity, and sometimes their paths cross. When that happens, entire galaxies collide. This is not a rare event. Throughout the history of the universe, galaxy collisions have shaped the structures we see today. And one day, our own Milky Way will face this fate. In about 4 billion years, it will collide with the Andromeda galaxy. At first, it might seem that such an impact would instantly destroy everything. But space inside galaxies is mostly empty, and stars are so far apart that most will pass by without direct collision. Yet the gravitational consequences will be catastrophic. As the two galaxies merge, their gravity will tear at each other's structures. Huge streams of stars and gas will be ripped out and thrown into intergalactic space. Other stars will be pulled inward, feeding the central supermassive black holes. In the end, the Milky Way and Andromeda will fuse into one enormous elliptical galaxy. To us, it will be the end of the galaxy we know, and the birth of something entirely new. What do you think is the most scary thing about space? Write it in the comments and see you in the next video.